graduate engineer and started my career from 1991 with the Dorsal and worked for DNV and sometime in offshore and worked with the government of Gujarat, various companies. And now I started my own organizations, which looks after the specializations of the pipelines, various pipelines, versus oil and gas, the slurry pipelines, uh, hydrogen, as well as the CO2. And I have a lot of expertise association with ASME as a trainer, as a voluntary member, and I'm the current chair for the pipeline system division globally. The second is the performance plan, and the third is the communication and management of change, and the quality control. The integrity management plan, we talk about the entire overview of what we are going to implement. And the performance, we don't need to check when we plan something, I think whether it is meeting that performance requirements or not. That has to be seen. How you do that, I think that's all the sections define that. And there's a communication system who all the people involved in implementing this during the course has to have proper communication, because there should not be any miscommunication why you are doing it, when we are doing it, how we are going to do it. This communication has to be the entire chain. And the management of change is very, very important. When there is a change in the pipeline operations, we need to communicate internally as well as externally also. So give an example of if you want to do a dent repair or wall thickness loss repair, you may be forced to reduce some pressure during the period of repair. So that information has to know the operations people, on ground people, as well as your customers, so that they should not worry about what happened, because the communication will make everybody clear. And quality control, before doing anything, I think there should be a quality plan. Are we going as per this? And the independent people will be checking that till the time it completely implemented. So the entire integrity, the program, I think is very well scripted into the simple process flow diagram. I think this one flow diagram will take care of entire explanation of this. The first most important thing is identifying the potential impacts by way of threats, because why we are worried about means where things can go wrong, because that's what we know that. And how, because there are different threats, because as per the standards, because 22 is already identified, we have to apply each threat and see that, I think what will be the impact on the pipeline. Before that, because to do that, we need to have a lot of the data. Means I think the fundamental, the integrity program starts on the data. So gathering of the data, reviewing of the data, and integration of these things is a big job for making a good integrity program. And then you apply the risk assessment. There are various methods of risk assessment, which we'll be covering it next slides. And then you apply all the threats. If everything is fine, I think you go to the integrity assessment methods, or you go back and then review another methods. And then once integrity assessments is done, we do the response out to the integrity assessments. So this is the flow we are going to do it. Like ISO, we do the plan, do, check, act. So collection of data, the data requirements, the data source where from you're going to get collected, then reviewing it, analyzing, and then throwing away the garbage and integrating it into the proper formats, which is very, very important to have a complete integrity management program. There are many data elements which is required. I just identified a few data elements here, because there are many like these things which are very, very important for the integrity point of view. So for this, I think we need to have the data which is coming from the route survey onwards, and the material transportation, the engineering, the construction, and the operations, because this is entire things is covered into this. But the biggest challenge is the data. Why is it is so difficult? The why it is difficult is the simple, because the data is generated from a different point of time. Because by the time it comes to the operations of the pipeline, cross-country pipeline, it takes almost 3 years. So from the day you start the survey or design and construction and then operations. So you have a different point of times the people will be giving, and the different groups of the people of the different departments of the organization, they do it. And there are different purpose of that, because somebody is doing survey, there are different purpose. Somebody is doing construction, there's a different. Engineering is different. And then they have different formats, and then they keep it in different locations, because these are all the difficulties of gathering all the data. That's the reason why we need to do all this process. The data acquisition itself is a set of difficult tasks. And once you have the data, there will be a huge data. I'm sure any of the project you do it. Out of that, I think take it good information and required data and put it in the soft formats, because that is more easy to extract and evaluate for integrity management. These are all some of the source where from you get the pipeline data elements. So you can have many things: pipeline alignment sheets, pipe books, and then you have construction data, MTCs, inspection reports, the testing reports, commissioning reports. So these are all where you get the required information for integrity management. So data security is again is a big issue. We are talking about the big data in 2020, but the security is also is becoming a big challenge. So once we digitize everything and then to look into the integrity point of view, uh, that purpose of putting everything together is to have a clear picture by sitting in one place. Because when we want to see a particular location of the pipeline, say for example at kilometer 3.5.7, so we need to have idea what all the issues at the particular point, whether it is high end, the low end, whether there is the CP issues also there is a coating damage is there. At that particular point, we need to know it, because not an entire pipeline section. So this data and digitization and integrating together will help a lot. And when we put all this data into the server, because there should be a proper access system and control system is to be ensured to avoid any unethical hacking, or even there are a lot of things we might have heard today, because even there are one or two pipeline incidents where because of cyber attacks, yeah, the pipeline got into abnormal operations. So we need to be very vigilant in the digital era, and I'm sure there are a lot of good things can happen because of artificial intelligence also in the soon. But we can't rely completely on this unless and until we have a robust access system for the data. So this is one good example how once we integrate the data at a particular chainage, because this entire one pipeline segment is mentioned here. Maybe a 20-kilometer section, we can see it from here. You can zoom, particular go there at a particular chainage and see everything. What is the condition of the elevation, the soil data, the ILI data, or the material conditions. So everything can be seen here. So this is the advantage of integrating entire data into a proper computerized system. So let's get into the risk into the pipelines. I think risk is one of the major important assignment, because today the team is also on the reliability. So for reliability, the risk assessment is very important. I'm sure, because risk is the simple definition. I think the probability of failure and multiplied by the consequence is what is the risk. But we understand, we normally take as a designers, we are always in mind that I think probability of failure of pipelines is very rare. So it's as good as zero. So that means the consequence is nothing. So the risk is zero. But risk will be never be zero. So we need to go into the details, and I'll give some examples how to do this risk rating and risk matrix, because then only we'll understand that I think it never be zero. I give one example. This slide is also very intentionally. I kept the impact, what happened if something happened on the pipeline, because we should not only look in the likelihood or the consequence. We should focus on the consequence, because if fail, what happened? Because most of the things we might have seen, the airlines normally the probability of failures are almost zero, but I'm surprised to see, because they've been very recent. There are a lot of air accidents took place. Even in December itself, we have seen 5 incidents globally. So it's very alarming, and I'm sure, because there is nothing uh, scared, but we need to have proper investigation, understand why things are going wrong. Because so many years, very few incidents, but in a month, so many incidents happen, and much more, because that is not the only area we are talking about. We are seeing natural disasters is increasing day by day, because we have never seen so many natural disasters in earlier days. But now you find a lot of flooding in the even cities, and the overflowing of rivers, somewhere landslides, earthquakes, and in cloud burst, because that's where I think even the pipelines are being exposed, because of short time, the heavy downpour is taking place. So these are all some of the areas where we need to see and carefully examine. We should not just ignore only the likelihood, but we need to focus on the consequence. So my focus here in this slide will be, even the pipeline or the CGD shall look or designed considering the consequence of risk rather than all the class and the normal safety requirements. So if you see, if the pipeline fails, what is the consequence? Because I'm sure any failure will be some loss of the damage to the property, the loss of life can be, and there will be some impact on the environment, because all three or maybe one definitely will be there when something goes wrong. So our objective is to prevent all these things. So the integrity, the standards gives very clearly how do you calculate the risk radius. 31.8S very given very clearly the dimensions and the formula. How do you calculate the risk radius? So what do you mean by risk radius? If you go and talk this risk radius, I was talking to one of the collector earlier about this. I think then immediate reaction is that I think with this, I think we don't allow any the pipelines to lay because the farmers doesn't allow do all these things, because I think so we need to explain this very clearly. So sometimes it backfire because we are not talking about risk radius means the for operators. I think this radius has to be considered as the high consequence area. So the proper precautions has to be taken, proper care has to be taken for the patrolling or the inspection. So whatever it may be, it doesn't scare the farmers or the local people. So there are the risk assessment methods. So it can be either knowledge based or scenario based, relative risks or probabilistic methods. So or any other methods, whatever is available. There are some companies, pipeline operators, they have their own risk assessment models. Anything is fine, I think, because for running all these models, we need to have a lot of data and we need to have a lot of experts who can understand, run these assessments carefully. Anything is fine because ultimately, because this is one of the good tool to take some risk assessments. So what is this risk assessment will do it? Because after running these tools or the matrix, what you are going to get it. So it doesn't stop anything to happen, but it will give idea for the operators or the integrity managers. So where can be the next failure happen? Because some ideas, because like we identified high consequence areas. Because why high consequence areas? So before I start, as a small disclaimer, because whatever the expressions I give here or present here today is all slowly my personal opinion and doesn't represent any of the companies or even the entity which I represent today. A broad outlines, because the integrity is a very big subject, so I'm not able to justify it in a short time. So I'll be focusing on key elements and the data, as well as the focus on the risk assessment, because since the theme is today given on the reliability, so I'll be more focusing on the risk part in detail. So before we go into this, so I'm sure because everybody be knowing about the pipeline integrity. So the first standard released by SME as a voluntary point of view, non-recommended in 2004, and subsequently a lot of amendment take place, and the latest one is 2022. So there are many definitions as a integrity, because this is not the only one, I think we should say. So there are many definitions. So I feel this is a very simple and able to express very clearly. It's a comprehensive, systematic, and integrated process that includes all activities that are required to prevent a failure. All our efforts are making here to see that there won't be any failure. So that's the basic purpose of the integrity management. So, as I'm saying, I think the codes and standards, which we'll be referring it, other than I think AMP also, they have something mentioned about the pipeline codes, and APIs also recommended practices are there. The main, the standards, what we follow is 31.8S, and the Petroleum and Natural Gas Regulatory Board also has released specific regulations on the integrity in 2012. So these are all main two which we'll be referring in India. Primarily, the integrity management have two parts of the standard. It is discussed in more in details. So one section talks about the prescriptive mode of integrity methods, and another way is the performance methods. The prescriptive is very conservative and but is easy to implement for all operators. Till the time I think the industry and the implementation is matured enough, so it's always better to go in the prescriptive method. Performance is more flexible compared to the prescriptive, but requires a lot of data analysis and then the back information for the operators to start with. Even the PNRB regulations also go on mainly on the prescriptive mode. this will ensure that I think because all the operators are following the same guidelines, same set of inspections. So today, I think the fundamental things which we'll be talking about is, are the pipelines safe? Or because this question being asked the several places when we go and talk in the webinars, especially we go to the colleges. I go sometimes spend with young professionals and some colleges. So the people are worried about the pipelines. So my answer is yes, the pipelines are very, very safe. Absolutely, there's no need to worry about it. But what we need to worry about is the product. So it doesn't mean I think the pipeline is safe because the product is safe. So our idea is to see that I think we make the pipeline safe so that the product is secured. So our entire effort is to see that the product doesn't go out of the pipeline. So before I go into the integrity methods or integrity systems, so I have a plan. I think I'm sure because I saw the program for today's program. Tomorrow there is a session on the learnings. And even I feel I think this is one slide I intentionally kept this because we need to revisit the scenarios of some of the major failures in the industry which happened last 2-3 decades. So it's very, very important. And these are all the forums where the persons who has really handled that incidents, who are we call it as in the safety first officers or the responsible O&M in charge or head, handle that particular incident should make a practice and then present here because that's what is important because we need to learn. I think every day we learn. We learn from others. We learn from others' mistakes or we learn from other countries. We learn from other operators. So, and of late, I've seen a couple of times in international two conferences where this practice has started. So even they take the scenarios to revisit of some accidents took place 2 years, 2 decades, 3 decades back, and people are seeing, I think, the scenario, what if now? So similarly, I think even I presented one case of the Narmada River exposures and where a lot of pipelines got ruptured in just a couple of days, which has happened. So it took a panic situation in entire that area, and in fact, because it's caused a lot of issues on getting the ROI also after learning from failures. So we need to be very, very clear about the failures of the pipelines. So I can just put one picture. I don't want to waste my time on this. So because we don't have talking about this today. Now, straight away coming to the integrity management elements, because when you talk about the integrity management, there are 5 elements which we are talking about in this. One is integrity management plan, and yes, because in the risk radius, if there is a school or the apartments or the hospital or something is very important from the government buildings, so we need to be careful about that. So this will give some ideas. Where are the hotspots? Like this is something example of high consequence areas. How many failures can happen? Because we know that I think because the things can go wrong here unless and until we take proper actions. And how to use your best resources? Because again, we can't do the repairs entire the pipeline. I think we need to prioritize these things and we'll at least know that I think how long this can withstand and when we should do the repair. So it's not necessary everything you do it today or in 1 month time. So this is the risk matrix, the tables. It's very, very simple, and this is most of the places it is used. Is not only in pipeline integrity. The majority of the areas this table is being used. So it's very simple. The consequence likelihood are mapped. High areas has to be done on the most top priorities, and the green one which we shows, I think that is the next level, and the white, the low things can be deferred for the time being. So that is not going to harm the pipeline. That is not going to be a major risk. So we need to focus on the gray one, high one on the top priority, so that when you have limited resources, any operators doesn't have so many resources available from the management. So use your resources first to attack the high areas and take mitigative measures. So some examples, it's already there. It's very easy to do it. How do you factors? So you take one probabilistic item and then you give the points. So how do you differentiate? Because there are main 4 parts you can do it. One is the third party index, the design index, corrosion, and operations. Because anything related to the metal loss, that all we clubbed into that corrosion. And operation issues, abnormal operations or malfunctioning, all things can be put into there. Maybe design areas where something is not done properly, this go into this. And third party damages all can go into that box. And then accordingly we take one example of the leak. So suppose if you want to break up these points of a leakage, 0 to 100, so you have to identify is one is environmental impact, and then there is the population where it's going to impact, and the loss of the product. So these three things will happen when there is a leakage. So if it is a normal leak, I think there will be loss of product. So you have to give some weightage. And if there is something accident take place, like we've seen some explosion, there we can have the fatalities. Then we need to rate accordingly. And environmental is also is impact, because today I've not seen any pipelines where it has been shut down because of environmental issues. But we need to take this thing. So this is numbers as given just for the understanding purpose, but we can give 0 to 40 for the population area, because that the life is more important rather than environmental point of view first. And second is environment, and third we can give to the product, because product is the loss of revenue. So that can be the least thing we should give it when something goes wrong in the public interest. So when once we do all these things, for a management to take the decisions or to give the financial approval or authority to do actions, so it has to be presented very clearly. What will be the impact on the environment? What is the impact on the financial, the bottom lines of the companies, and the safety of the people, the public? So then the management can easily take a decision and give some directions to the integrity team. So now coming to the, we talk about the integrity risk assessment. Now talking about integrity assessment methods, because I'm not going in details, looking into the time, because integrity assessments is only three methods we have in entire the system. There's no confusion. This is very clear. The first one is hydro test. Second is inline inspection. Third is direct assessment. So we should review these methods in order, because first, as long as it's possible, if you can do it, the hydro test at appropriate time, so that's the best integrity assessment methods. But unfortunately, we cannot stop the pipelines and supply. We can't disconnect to the consumer. So it's very rarely possible unless and until there's a spur lines which is going to the either a refinery or the fertilizer or the particular plant, where even the plant they shut down. That time, I think you can do it. And the best and easy way is to inline inspection, because you don't need to interrupt the flow, or you need to even no need to reduce the pressures or the flows in maximum pipelines. Maybe some spur lines you may have to have some interruption of some supply or the pressures. And third one is the direct assessment. The direct assessment is also is good method, but where these first two things are not possible, you can go for the direct assessment. And where you can't do this, even the pigging, so these the pipelines they can go for the direct assessment. So I think this is the order of the precedent for integrity assessment for anyone to do it. So this slide is again coming in the CGD perspective. So utility mapping, this is one of the biggest concern, because I'm associated with the CGD since 1996. Unfortunately, at least my personal opinion is that I think the safety and the quality has to go up. The graph, I think the graph is coming down. So the main reason is because we don't have utility mapping at the district levels, and everybody have their own maps, because there is no common maps. And in fact, even last 1 week, because there is a lot of excavation going on in front of my house for the drainage purpose. So they broke water pipeline, they broke the gas pipeline, they broke the power. So everything is there, and all the concerned disciplines are also there, and things going wrong, because the reason is because there is no common utility mapping system which we can easily apply and prevent all these things. Because one is the damage cost and inconvenience and the safety. All three things we can minimize. And I'm sure, because this model was discussed, but it is not taken shape as of now. And I think this is the need of our for reducing the accidents and then inconvenience to the customers. And a lot of awareness is also is required for the operators in that. I think this one good examples. We are talking about cyber security, and then we are talking about even other way around this thing, because these things do happen because of lack of awareness. We need to do a lot of awareness programs as well as CGD or even the pipelines. And lastly, without taking much time, I'm sure because I'm doing in my own given time. So to sum up, I think risk analysis shall be integral part of the operator integrity management program, and fully matured process are rare in the industry. So nothing to worry about it. So the choice of risk assessment is best left to the operators because they are matured enough. They have enough data now. All the operators. There's no new operators. So I think this is left to the operators to decide. And subject matter experts be engaged for independent review and evaluations of especially the high consequence areas. So this is a good idea to have a second opinion. And with the proper integrated management system, and I'm sure the assets can go much beyond the design life. Though we write 25 years, 35 years design life, I think there is nothing expiry of design life for the pipeline system or the even the CGD. So if you have a good integrity management system, I think it can go much beyond even the double the design life what we do in the design documents. So thank you for your patience hearing. Have a safe operations. Thank you.